Hi everybody, welcome to Unit 2, Video 3. If you do not have your notes out, please go ahead and get your notes out now. All right, so let's take a look here. It says, I can factor polynomials by using the GCF, the greatest common factor, by recognizing special products, and by grouping terms. All right, so let's go ahead and take a look at this one. So first you want to do what they say is saying, is there a GCF? So between here, does 3x squared and 6x have a greatest common factor? So they do. 3x squared and 6x have a GCF of 3x. So you want to go ahead and factor that out. And remember, factoring is like, I don't know what's wrong with this pen. Factoring is when you, there we go, are like dividing it. So if you want to think of it as 3x, and then you're simplifying it, that's one way to think about it. So when you simplify here, you'd be left with x. On this side, you'd be left with plus 2. So then this is our answer, 3x parentheses x plus 2. And you could check it by doing some mental math. If you distributed 3x back to both terms, you should get 3x squared plus 6x. All right, let's take a look at the next one. Between 11x squared minus 33x cubed, do they have a greatest common factor? Yes, they do. 11x squared. So remember, the greatest common factor for the exponents is going to be the lowest exponent they have in common. You can't say x cubed because there's not a cubed within a squared. So, but there is a squared, or there's two x's within the cube. So we're going to take out the 11x squared. So 11, let's try this again, 11 x squared. So again, it's like dividing it. So if we were to divide 11x squared by 11x squared, we'd be left with 1. If we simplified here, we'd be left with minus 3x. And again, remember, you can check it by doing your mental math. Distribute back in and see if you get 11x squared minus 33x cubed. Okay, so let's go ahead to number 3. Oops. And where did it go? Okay, so number 3 here, we want to go ahead and look at and say, what is the greatest common factor? So with number 3, the greatest common factor here would be an 8xy. So 8xy. So when you factor out that 8xy here, you'd be left with 3x minus 5. And again, if you want to put that 8xy underneath, and then simplify, that's a perfectly fine way of doing it, okay? So I want you to go ahead and pause the video and you try to do number 4. Okay, so let's see how you did. So the GCF here was a 6r squared s, because this was, remember, the lowest exponent they have in common, s. So when you factor that out, you're left with 3s squared plus 2r squared. Okay. So that was factoring out a greatest common factor. So now what we need to look at here is we need to take a look at our special cases. So this special case is a perfect square trinomial, or trinomials, because there's 2 of them right here. So perfect square trinomial. And so this is a trinomial. And if you notice, the 2 ends here are perfect squares. You have a squared and b squared. So if you follow this rule, that if you took the square root of a squared, the square root of b squared, and you put them like this, you'd have a plus b. So if you squared the first term, you get this term. If you multiplied these, a times b together, and then multiplied it by 2, you'd have the middle term, 2ab. And if you squared the last term, then it means it's a perfect square trinomial, and you could go straight to its factored form. Same thing with a negative. If you have a squared minus 2ab plus b squared, if you took the square root of a squared, so a squared root squared b, and there was a minus in the middle, and you said a squared, and you multiplied these 2 together, a times negative b times 2, and you got the middle term, negative 2ab, and squared the last one, so you got a plus b squared, it would be a perfect square trinomial. So let's take a look at it with numbers. So let's try this. The square root of 4y squared would be 2y. The square root of 25 would be 5. And so if I put a plus sign in the middle, let's see if my perfect square trinomial holds true. So if I square the first term, 2y squared, I get 4y squared. If I square the last term, 5 squared does give me 25. If I multiply 2y and 5 together, that gives me 10y. If I multiply that by 2, that would give me 20y, which I do. I have here in the middle, 20y squared. So that means this is a perfect square trinomial. And you could check it. If you wanted to check it, you could write this out twice. 2y plus 5 plus, sorry about that. So 2y plus 5. So you could say 2y plus 5 times 2y plus 5. And you could go ahead and do the math and see if you got the middle term. But remember, whenever you multiply something by itself, it's the same as saying quantity squared. All right, so let's go ahead and check this next one here. So we have 121x squared minus 66xy plus 9y squared. So let's go ahead and see if it is a perfect square trinomial. So the square root of 121x squared would be 11x. The square root of 9y squared would give me a 3y. In this case, there's a minus in the middle, so I'm going to put a minus in the middle here. So we start with the first term, square it. 11 squared is 121 squared. Square the last term. Negative 3y squared is a positive 9y squared. If I multiply these together, I'd get a negative 33xy. If I multiply that by 2, I do get negative 66xy. So that means this is a perfect square trinomial. Okay, so I want you to go ahead and pause the video and see if you can do numbers 7 and numbers 8. All right, so let's go ahead and see how you did. So these two are both perfect square trinomials because when you took the square root of p squared q squared, you got pq. When you took the square root of 36, you got 6. And then since this is minus, we put the minus sign in the middle. So then when we checked it, we know pq squared is p squared q squared. 36 squared, or 6 squared is going to give us 36 squared. When you multiply these together, you get negative 6pq times 2 is negative 12pq. All right, let's take a look at number 8. So the square root of a to the 4th is a squared. The square root of b to the 8th is b to the 4th because, remember, same base multiplication means you're adding the exponents. So 4 plus 4 does give you 8. Then when you multiply these together, you got a squared plus, or a squared b to the 4th. So when you times that by 2, you got 2a squared b to the 4th. So again, these two both are perfect square trinomials. Okay, let's take a look at another special case. This one's called difference of squares. All right, so when you take a look at the difference of squares here, we have this form, a squared minus b squared. So when you factor it, you could go to a plus b and a minus b. Because if you notice right here, if you were to multiply a times negative b, that'd be negative ab. And if you try b times a, it's a positive ab. And a negative ab and a positive ab would cancel, which means there is no middle term. All right, so let's put some of our rules together. The first rule that we talked about was always look for a GCF. So what you want to start with here is say, is there a greatest common factor between 16x squared and 4? And there is. It is 4. So the first step you want to do is factor out that 4. So if you factor out a 4 from both of these, you're left with 4x squared minus 1. Then you want to look at it again and say, okay, is it a special case? Well, we know it's not a perfect square trinomial because there's not 3 terms in it. So, but is it a difference of squares? Well, there is a minus sign in the middle. 4x squared, it's a perfect square, and 1 is a perfect square. So let's go ahead and factor it. So I'm going to bring down this 4, this GCF on the outside. It has to stay there. And I'm going to write 2 parentheses. So 4x squared. So the square root of 4x squared would give me 2x and 2x. Okay? The square root of 1 is 1 and 1. And if I need this middle term to cancel out, it means one of my signs has to be positive and one of my signs has to be negative. So when I check this, I'd get 4x squared. Here in the middle, I'd get a positive 2x. On these two outside terms, I'd get a negative 2x, which means they would cancel out. And 1 times negative 1 would give me a negative 1. So this is my completely factored form. And remember, you want it completely factored, so you have to factor out that GCF. All right, let's try number 10. Again, you always start by saying, is there a greatest common factor? Yes, in this case there is, x. So I'm going to factor out an x from both sides. So when I do that, I'm left with y squared minus 1. All right, so then I want to check, is it one of my special cases? Well, there's a minus sign in the middle, and there's two terms that are both perfect squares. So difference of squares. So I'm going to bring down that x that I factored out. I'm going to write my two parentheses. I'm going to say, okay, the square root of y squared is y and y. The square root of 1 is 1 and 1. And since I need the middle term to cancel out, 1 has to be positive, 1 has to be negative. And again, you can do your mental math to check that you would get back to your original answer. All right, I would like you to pause the video and try 11 and 12. All right, so let's go ahead and see how you did. So first we checked if there is a greatest common factor, and there isn't. But then I checked, okay, are they both perfect squares? 81 is, 4x is, and there's a difference or a negative in the middle. So yes, it is a difference of squares. Here's what the factored form would look like. Let's check number 12. 36x squared, that is a perfect square. 49y squared, that is a perfect square, and there's a minus sign in the middle. So the square root of 36x squared left us with 6x. 49y squared gave us 7y and 7y, and since the minus sign was in the middle, one has to be plus, one has to be negative, so that those middle terms cancel out. All right, let's go ahead and go to the next page. So the page that we just did, those problems were probably familiar. You probably saw them before in Algebra 1. Now, these ones, you might not have seen these special cases. So this special case here is called the sum and difference of cubes. So just like we had a difference of squares, now we're talking about the sum and the difference of cubes. So if you look here, we have a cubed plus b cubed. So when you have something in this form, it can be factored this way. You take the cube root of a cubed, which gives us a, the cube root of b cubed, which gives us b, and then we take these terms. We square the first term, we multiply a times b together, and we switch the sign, so we get negative ab, and then we square the last term. So this would be the factored form of a sum of cubes. For the difference of cubes, it's very similar. Again, we have a cubed minus b cubed. So we take the cube root of the first term, so a. We take the cube root of the second term, so b, and we put the minus in the middle. Then we square the first term, so a squared. We multiply a times negative b, which is negative ab. Then we switch the sign, so plus ab, and then we square the last term, which is going to give us a positive b squared. All right, so let's go ahead and check this one out. So we have x cubed plus 8. So we want to start with this, okay? It's a sum, and these are both cubes. So we take the cube root. So the cube root of x cubed is x. The cube root of 8 is 2. And since there's a plus sign in the middle, I have x plus 2. So then what I need to do is I square the first term. So this is x squared. I multiply a and b together, so I get 2x, and I switch the sign. So that becomes a minus 2x. And then I square the last term. So 2 squared is going to give me a positive 4. So then this is my factored form. And again, you could check it. You can make your box, multiply everything, and check that you get back to x cubed plus 8. So you could check it if you wanted to. All right, let's try the next one. So we say, is 27x cubed a perfect cubed? It is. And is 1 a perfect cube? Yep, it is, because 1 times 1 times 1 is 1. So let's take the cube root of x cubed. That's going to give us 3x. Because remember, 3 times 3 is 9, times 3 is 27. The cube root of 1 is 1, so I'm bringing down this minus 1. Okay, then remember, I'm following my rule here. So I take the first term and I square it. So 3x squared is going to give me 9x squared. I'm going to multiply these two terms together. That's going to give me a negative 3x, and I'm going to switch the sign. So it becomes plus 3x. Then I'm going to take the last term, and I'm going to square it. So negative 1 squared gives me a positive 1. And so there's my factored form. Okay, so I want you to pause the video and try to do numbers 15 and 16. See how you did. So we have x cubed y to the 6th. So that is a perfect cubed. Because remember, y to the 6th, when you're multiplying same base, you add the exponent. So y squared plus times y squared would be 2 plus 2 plus 2, which is going to give you the 6th in the exponent. So you take your first term and you square it. So you get x squared y to the 4th. Then you multiply a and b together. So we have 4 times xy squared, and you switch the sign. So plus 4xy squared, and you square the last term. So plus 16. All right, let's take a look at number 16 here. So 8 is a perfect cubed, u cubed is a perfect cube, and v cubed is a perfect cube. So when I take their cube roots, I get 2u plus v. So I'm going to take my first term and square it, which is going to give me 4u squared. I'm going to multiply these two together and switch the sign, which gives me negative 2uv. And I'm going to square the last term, which gives me v squared. All right, let's take a look at number 17. So with number 17 here, again, we want to remember our first rule of factoring. You always want to decide, is there a GCF? So is there a GCF here? Yeah, there is. There is 2u. So you want to go ahead and factor out a 2u. So when you factor out that 2u, you would be left with u cubed plus 27. Okay, so now that you factored out, you want to check again and say, is this any one of my special cases? Well, u cubed is a perfect cube, 27 is a perfect cube, and there's a plus sign, so I know it's a sum of cubes. So what you want to do is bring down that GCF of 2u, and then let's go ahead and take the cube roots. So I have u plus 3. Then I want to square my first term, so u squared. Multiply these two terms together and switch the sign, so negative 3u, and square the last term, plus 9. So then this whole thing here is my fully factored form. All right, I want you to pause the video and try number 18. Okay, so let's see what you got. So first rule, GCF, there was a GCF here, 5a. So you want to go ahead and factor out that 5a. So you're left with a cubed minus 1. Then you want to check, is it any one of our special cases? And this one is, because remember, 1 is a perfect cubed. So you have a cubed and 1, which I can take the cube roots and get a minus 1. Then I followed my rule and I said a squared. Multiply these two together, which gave me negative a. So switch the sign, positive a. Square the last term, plus 1. All right, so now we have some that are special, really, really special, because now you can factor within a factor, okay? So you always want to make sure that it's fully simplified. So first what you want to look here and say, okay, is this one of my special cases? So x to the 4th minus 81. Well, it's not a cube, but it is a square, a difference of squares, because x to the 4th is a perfect square, 81 is a perfect square, and I have a minus sign in the middle. So that means if I factor this here, I'm going to get x squared minus 9 and x squared plus 9. But remember, we said this is a special case. So you're trying to see, is it able to be factored again, or is it completely factored? So you check it again and you say, are either of these two another special case or something that can be factored again? And if you notice, this first one is x squared minus 9 is also a difference of squares. X squared is a perfect square, 9 is a perfect square, and there's a minus sign in the middle. So that means here, this can get factored into x minus 3 and x plus 3. All right, so let's look at our next term. X squared plus 9 is not a special case. There is no sum of squares. There's a sum of cubes, but not a sum of squares. So I can't do anything with this, so I'm just going to bring it down. So x squared plus 9. And so since that's all I can do, and now it's fully factored, that is my final answer. Okay, so you try 20, and remember, it is a special case. So let's see what you got for number 20. So if we take a look here, it's special because it could have been done two ways. So this first part here is a difference of squares. So if you took the square root of x to the 6th, you get x cubed. The square root of y to the 6th would be a y cubed. So, and there's a minus sign in the middle, so that means one was negative, one was positive. But then from this point, if you looked at it again, it was a difference of cubes, which means they both could have been simplified one more time. So this was a difference of squares, a difference of cubes within a difference of squares, okay? Or you could have factored it this way. You could have started off and said, well, it's a difference of cubes, because the cube root of x to the 6th would be x squared, because x squared times x squared times x squared gives you x to the 6th. And the same thing with y to the 6th. It's a perfect cube. Its cube root would be y squared. So you could have started off by factoring it as a difference of cubes, but then you would have noticed that x squared minus y squared was a difference of squares, which could have factored into x plus y, parentheses x minus y. And so I know they're slightly different in the answers here, but when we get to the solving for them, if you were to set them to 0 and find their roots, you would get the same answer. So it's okay if you factored it either of these two ways. You just have to be careful. It has to be fully factored. So you want it in the complete factored form, which I have as boxed here, okay? So you always want to make sure you look for those. Could it be simplified even more? All right, thank you for watching the video.